And we're going to go ahead and get started. So welcome to the WastewaterSCAN stakeholder meeting. It is 2024 now. Happy New Year, everybody. I hope you had a restful and peaceful holiday. We show this slide at the beginning of all of our presentations, who we are. We're a national effort based at Stanford, and we use consistent methods for monitoring diseases through wastewater to inform public health responses locally and nationally. Marlene and I, who you know well, are the program directors, and Marlene is at Emory. Verily is our scaling partner, as is National League of Cities. And then all of you and more who are not on this call, who can't make this time and watch it recorded, are stakeholders, our public health officials, the wastewater treatment plants. This project would never be possible without you, and we are so grateful for your participation and willingness to collaborate and work with us. So thank you very much. An overview of our program. We are currently working with 192 wastewater treatment plants across the United States, representing 13.5% of the US population, and 41 states are represented. So you can see this map here showing all of the participating states and the size of the different populations served by the wastewater treatment plants that we work with. These are the pathogens that we're currently monitoring. We have chosen to, with your input, to focus on important seasonal and emerging respiratory pathogens listed here, important enteric pathogens listed here, as well as emerging and outbreak pathogens of concern listed here, including Candida auris, hepatitis A, and Mpox. And we are now also sequencing SARS-CoV-2 from about 30 sites. And we have our controls here that we also run on every sample. The sequencing methods that we're using are, we're doing whole genome sequencing from nucleic acids from wastewater solids. We're using the tiled amplicon approach, which is quite commonly used for this. And we're using the Freya pipeline for bioinformatics. We have our protocol on protocols.io, and data are now available on the WastewaterSCAN site. And soon we'll be showing nationally aggregated sequencing data. So this is an example of how the data look. Each week, there is an estimate of the proportion of different variants, and they are distinguished by color. So these data are from San Jose, California, and they show that this red here is the most common. That's JN.1, which we've been hearing about so much in the news lately. And then this dark red is the BA.2.86. So these colors will change over time, and the labels will change as different variants become more prevalent and change, as they always do. To show you how to access these data, I took a screenshot of the website. So basically, the way to access these data is that you go to a specific site, in this case, San Jose, and if sequencing data are available, the sequencing button here will be active, and you can click on it and you can look at the sequencing data. So since we are only sequencing data from 30 sites, this button is not active on all the sites. So we have a list of all the sites we're sequencing from, and we've shared that information in the past. And you can go to your site if you have forgotten or you're curious and see if sequencing data are available. We are only able to do sequencing for 30 sites, so unfortunately we can't do all of them, but we tried to pick sites that we thought were very representative and spread across the US to provide some data that would be local, more local to all the stakeholders. So we're excited to have these data, and we'll be including snapshots of them in our newsletter. And as the national data aggregation becomes available, we will share with you how to access that and be sharing that. So probably next week that will be available. All of our protocols and papers are publicly available. We always provide this information to you. It's also on our website, or you can reach out to us if you want access to papers. They're all open access, and these QR codes will take you directly to the websites. And then last time we met, we alerted you of our new paper on influenza A. across the United States, and that is available here. And we think that next time we talk to you, we'll have a similar sister paper on RSV that is currently accepted. It's like in minor revision right now. So we hope to have good news on that soon. Okay, so now I want to talk about the announcement about the influenza A assay. So we sent an email last night, and I'm just going to repeat the information in that email. So this week, we identified a performance problem with the influenza A probe that was labeled with a fluorescent molecule called Psi 5.5. This molecule was not fluorescing as it should in the wastewater samples, although it was working fine for all the controls. We did some investigation with Verily, who acted extremely quickly to do this work and drop everything to figure this out. And we found out that if we replace this fluorescent molecule with ROX and Atto 590, that it performs well. So starting today, all the influenza A measurements will be made using a new probe with a new set of fluorescent molecules. The impacted samples that are impacted by this fluorescent molecule are from October 2023 to present. So we have temporarily removed the influenza A data from the data.wastewaterscan.org website while we remove the impacted data from the data set. And hopefully we'll have the unimpacted data back up within a week. I think it will be much quicker. Ideally, we could have it back today, but we just want to not make that promise because we want to do it right. And we will be rerunning a subset of the impacted samples from your site to repopulate the data that will be removed from the website. So what this means is that the magnitude of the concentrations that we were observing this season with the impacted data and last season are not comparable. So I hope that's clear. Just to make sure it is, I'll just repeat it because as I wrote it on the slide, I think it's much clearer than as I ad hoc'd it. The magnitude of the concentrations this season and last season are not comparable until the impacted data have been replaced, which they will be. So I hope that's clear, and we will take questions about this at the end of the presentation. And one thing I didn't mention on this slide is that in order to run the influenza A assay with these new fluorescent molecules, we have to stop measuring the adenovirus because the adenovirus currently uses those fluorescent channels. So we'll be replacing the adenovirus with the influenza A in those channels. Okay, so with that, I'm going to pass it to Marlene to go over all the data. And I also want to add, no other data is impacted. It's just influenza A.
Yeah, thank you. And again, we'll have some time for questions and such, and feel free to drop questions in the chat as we go, but we want to go over the wastewater categories for the rest of our targets. Also, if you're in the Midwest experiencing thunder snow, I hope you're doing okay, because your storm is headed down to us in Atlanta now, I think. Okay, so categories. So as you know, our categories are based on thinking about level, trend, and frequency to meet this need of a clear way to communicate what wastewater is telling us about community disease circulation. I know for many of you in kind of the communities that you work with, and as you're communicating about this data, a lot as I talk to my friends and family, looking at these charts and having a good sense of what it means for current circulation requires a lot of interpretation of data. And we want to make that a little bit easier for people as they're trying to make sure that they understand what it's telling us. So trends tell us how things are changing, right? Going up or down or staying steady over time. Levels tell us whether cases are relatively higher or lower. So we'll look at the concentrations in comparison to other time periods. And then the frequency of detection is especially important for rare targets where we're not always detecting that particular target. So that's what our categories are based on as a little refresher for the new year. Next slide. We have 3 different archetypes for the wastewater scan pathogens. So pathogens that are commonly detected regardless of season. We have one approach where we're just looking at the levels and the trends and considering both of those to determine a category. For seasonal pathogens, where we're not detecting them all the time, there might be a good portion of the year where we're not detecting that pathogen, but we expect regular outbreaks to happen. We use another method where we look at the start and onset of the season by seeing when detections begin to become consistent, and then we look at levels and trends. And then for pathogens that are not commonly detected regardless of season, we don't expect them. We look at the number of positive detections that we see in samples over a recent period of time from a given location. So we are currently applying these categories for the pathogens that are listed here. We will likely begin category analysis for some of these new and recently added pathogens soon, as we've been establishing a couple months worth of data now, but categories for those are not yet available. So now we'll look at kind of where we currently are. So here's an overview. Again, we are leaving influenza A out of this analysis for right now. And then, very soon we'll be able to report back on influenza A. But overall, what we see is with SARS-CoV-2, the category that we've designated for it right now is high. There is a little bit of a downward trend at the national level right now. The concentrations are very high. So these concentrations that you see here on the top left plot, you can see there's been a little bit of a downturn recently, but that peak is higher than what we experienced last winter by a good bit. For influenza B, we have seen we're in the low category right now. Less than 50% of the sites around the country have seen that onset of influenza B. That being said, the concentrations are much, much higher than they were during the summer period when we have very little influenza B activity. And we are, seeing that there also appears to be a little bit of a dip there recently, but the influenza B concentrations have gone up significantly in the past couple of months. So hopefully those will start coming back down. RSV is also in the high category. We have more than 50% that had that onset. We have no trend right now, so things are staying flat and at a very high concentration. So we're at high levels right now and staying there at this point. So RSV, is still something that we're definitely keeping an eye on. Human metapneumovirus, you can see on do you want to point at the chart, Allie? Sorry. You can see that there's been a little bit of an increase in human metapneumovirus recently. We're still in the low category because less than 50% of sites are in onset, but there is, some increase in measured concentrations around the country. And then norovirus is in the high category. We have had an upward trend recently and high concentrations. So you can see that from that summer period of a low, we are back up to pretty high levels for norovirus. And then Mpox is in the low category with very few positive samples. We'll dig in a little bit more into each of these. So this is the SARS-CoV-2 data, the data for COVID split out by region. So we have the Midwest, the Northeast, the Southern US, and the Western US. And you can see that there aren't dramatically different patterns that we're seeing in these different regions of the country right now. Overall, we have been experiencing very high levels of SARS-CoV-2 in wastewater, and we are hopefully seeing a little bit of a decrease now. But a decrease at a high level is still a high level of SARS-CoV-2 in wastewater. And this is the category map where you can see that the majority of the sites and all regions are in the high category. So again, for RSV, we see very high rate of detection. 94% of all samples have been positive for RSV. You can see here on the right some of the positivity rate data from CDC for RSV, which matches the same shape as our recent data. And we will have to see sort of whether this beginning of a downturn that we're seeing is is true is going to happen. Again, that is not statistically significant in the wastewater data. It is still, the trend is flat. And so, hopefully this will be the peak. And this is the category map. Again, the vast majority of sites in the high category and all regions. Influenza B. So we have had many samples that are positive, although overall, we haven't hit the threshold of number of sites that have significant influenza B activity to put it in a higher category nationally. There are a number of sites that are in higher categories individually. And you can see in this plot, there does appear to be a little bit of a downturn recently in the influenza B concentrations in aggregate across the country. That's not yet reflected in the positivity rate data, which does lag a bit behind this data, and the clinical data on the right is through December 30th. So we're hoping that that same dynamic of a downturn will kind of be confirmed in the positivity rate data and will continue. This is the category map, so you can see that the South is in the high category for influenza B, and a number of sites, 58 of 192, are also in the high category. So a good amount of influenza B going around when you drill in on the individual site level. Then human metapneumovirus. So again, our clinical data lags a little bit behind the wastewater data, but there is a bit of an increase we're seeing recently in the positivity rate data from CDC that aligns with the increase that we've seen recently in the human metapneumovirus data. And we will continue to watch that. Category is still low overall, with only 18 sites popping into the high category and 5 into medium. And then finally, norovirus. So norovirus, again, the kind of shape of the curve of what we're seeing in wastewater matches the positivity rate data from CDC. Norovirus is very highly abundant in wastewater. So this is one of those where we measure it very consistently, but you can see there is a big difference in those low levels that we see during the summer period. And then kind of a previous peak that happened in around March. And then now this year, it is the beginning of January. So we'll have to see whether how we will go with norovirus. Not yet determined, but norovirus levels are high, and we're in the high category in wastewater. This is the category map. So again, the West is in the medium category, but other regions are in the high category. 117 sites in the high category, so a very large percentage experiencing a lot of norovirus. Okay, thank you. I hope that wasn't too fast, but I wanted to speed through some of the category stuff because we do want to leave some time for your questions. Whether, any more questions about influenza, we're happy to answer, or any other questions that you may have coming into the new year. You can speak up or write in the chat if however you'd like to ask.
We have a question in the chat about the timeline for WastewaterSCAN for the new year. Colleen, we are still planning to continue until May 2024, and we hope to be able to provide some more details about that soon as we can. Did I say 2025 or 2024?
I think you said 2024. 2024 is correct.
Okay. I don't even know what year it is anymore. Oh, for the other, so Colleen is asking about trends for the other pathogens. Do you want to take that one?
Yeah, good question. So it is still on the early side to tell. Stephen, who's on the call right now at Emory, has been doing some work looking at applying the category analysis that we've been using to these new pathogens. And I think it's looking good. It's very useful. And so we're optimistic about including some, if not all of those in the category analysis soon. I hope that we'll have an update on that for you by the next stakeholder meeting, if not sooner, but it is, important, particularly for the seasonal pathogens, to have more benchmarking of what we expect during sort of in season and then off season levels. So there will be differences in when we're able to deploy categories for new pathogens, depending on which one of those archetypes they fall into. We have been working on it. Stephen's been working on it, and we'll have more updates for that soon.
I think something that Marlene and I learn as when we're teaching classes, and those of you on this call who are also have to teach students, is when you ask if there are any questions, you just wait, and then questions will come. So we don't mind the silence. Colleen, did you want to talk? You have your hand raised. Thank you for all your questions. Colleen, go ahead.
Yeah, I don't want to dominate or hopefully, yeah, people feel free, others to ask questions. I was just maybe a little confused on the flu A like changes. So it's not really like an assay, it's a specific uh how did you call it?
Fluorescent molecule.
Yeah, fluorescent molecule. So it's still gonna
Yeah.
be comparable data. That's
Yeah,
different than I've heard
Yeah.
before. Yeah.
yeah, and I mean that's it's a little strange and an unexpected issue, which is why it happened. But yeah, it relates to the fluorescent molecule, the Psi 5.5, which might not mean anything to some of you, but each of the probes on the assay has a fluorescent molecule, and as the copies of it are made in the PCR reaction, the fluorescence becomes higher and higher, and something was affecting the performance of that particular molecule in the wastewater. So it's not the assay, it's not the sequence of the primers or the probes. However, it is interesting that you asked that, because that is also something that we always have to keep an eye on for all of these assays, especially, we've seen SARS-CoV-2 mutate over time. And so it's something that we always have to keep an eye on, because all of the targets, like, potentially could mutate. So that's something, in general for wastewater-based epidemiology, we have to keep an eye on too.
Yeah, and Angela has asked in the chat, how did we pinpoint October as the start of the issue? Was there a change made to the probe at the time? So interestingly, there was not a change that was made to the probe at the time, but there was a change that was made in some of the other assays that we were including. So it's the same molecule, but sort of in the arrangement that it was in was changed. And we believe that is apparently what resulted in the issue. So as much as we did, thoroughly test the molecules before making the switch, the machines and the way that they were handling that data started having an issue around that time.
And Colleen, the answer to your question is no. I'm sorry if I kind of like went on a tangent, but it's not related to a mutation in flu A. It's entirely an artifact of this fluorescent molecule attached to the probe, not performing as it should have. I hope that's clear. Sorry, I was going on a tangent about how that was also something important that we do keep an eye on, but that was not related to this issue. Is that clear?
Yeah, sorry about that. I'm being the student that misunderstands. So
No,
appreciate it.
I'm glad that you articulated that, because I didn't want you to misunderstand. And if you did, then other people may have as well.
Elizabeth, yes. And, we will do some more testing to make sure that we have confidence in that. But we do expect that with the assay performing as it should, the magnitude of those concentrations will be comparable to the measurements that we made last year, which is why we really want to make sure that we do go back and rerun a subset of samples so that that kind of visual of the curves over time is consistent for future use. But as of today and the new data from today, we will kind of return to data that's not impacted, and we will have that up again on the website as soon as we can.
Okay, that's great to hear. Thank you.
Brad, did you want to add anything? I saw you on.
Sure. So we noticed that, so we also do testing, as most of you probably know. I'm from Verily, Brad, for the CDC news program as well. And influenza A is in a different channel for that program. And we saw that the concentrations of influenza A were increasing a lot for the samples that are being tested through the CDC workflow, and similar to what's actually happening with clinical cases. And so that suggested that something was up with the WastewaterSCAN data, because we're not seeing the same kind of increase in influenza A with the WastewaterSCAN data, and caused us to do a comparison of influenza A in different channels and with different fluorophores. And it is this Site 5.5 fluorophore that's causing the issue with the WastewaterSCAN. So looking at that, I won't say too much about the CDC data, but I do think the levels are comparable to what we were seeing last year. And that we'll see that when we go back and do this retrospective filling in the gap of this data for the WastewaterSCAN plants.
Thanks. And yeah, I just really want to thank Verily for working so hard to fix this. I mean, a lot of us work with students and postdocs, and I love them, but they would have taken 2 months to figure this out. And the amazing team at Verily sort of worked really hard to get a solution to this within days of really realizing there was an issue. So really grateful for our team.
Yeah, and
Well,
I also want to reiterate that the issue is specific to influenza A. And so we're confident that the other data is not impacted, does not have this same probe, the same issue, any of that.
It's 9:30, so we're gonna go ahead and stop recording and end the call. If you have